Assalamu alaikum and good morning my dear students, colleagues and friends. In this video I'm going to show can we use correlation coefficient to measure relationship between two variables when one variable is quantitative and another variable is categorical. Before this we used correlation coefficient to explain relationship between two continuous variables, and that was straightforward. And as you know, the correlation coefficient ranges between -1 and +1, where +1 means that there is a perfect positive correlation between two quantitative variables, and when the correlation coefficient is -1, then in that case there is perfect negative correlation between the two quantitative variables. We can also measure the strength and the relationship of the relationship between two quantitative variables, and if the correlation coefficient is between 0.1 and 0.29, then we call that weak correlation between the two variables, and when it is between 0.3 and 0.49, then it is known as a moderate or medium type of correlation. And if the correlation coefficient value is between 0.5 and 1, then this is a strong or high correlation between two variables. Now a question is, when we have two variables, when one is quantitative but the other variable is binary, dichotomous or categorical variable, then in that case we use a correlation coefficient to measure the relationship or association between two variables. So the question is that yes, in that case we can calculate the point biserial correlation coefficient designated as R sub PB, which is a statistical measure that quantifies the strength and direction of the association between one continuous and one binary categorical variable. It is essentially a specialized case of Pearson correlation coefficient, which is specifically designed for situation where one variable has only two categories. The sign of the correlation coefficient, as I mentioned earlier, indicates the direction of the correlation. If the sign is negative, then we can say that there is a negative correlation between the two variables, and if the sign is positive, then we can say that when one variable increases, the other decreases, so there is a positive correlation between the two variables. The strength of the relationship between the two variables is measured by the value of the correlation coefficient, and I have already told you that there could be a weak correlation, there could be a moderate, and there could be a strong or a high correlation between the two. So if we have one quantitative variable and one binary dichotomous or categorical variable, then in that case we can do the same to estimate or to compute point biserial correlation coefficient between the two. So how can we do that? For that, let me go to my SPSS data. I have already opened this file that is titled as data analysis for my MPhil students, and it has a number of variables. Education is one categorical variable, health is another categorical variable. This is marks in statistical analysis and interpretation. These are marks in research. This is gender, where 1 is equal for male and 0 for female. This is a marks in statistical analysis and interpretation after training. These are categorical. This is categorical variable program having 3 categories: 1 journal, 2 academic, and 3 vocational. And finally, this is one categorical variable where 1 stands for the students who have studied science in high school, and 0 for those who have studied humanities humanities in their high school. So let us discuss how can we measure correlation between marks obtained in statistical analysis and this binary categorical variable. So I want to see whether marks obtained by students who studied science in their high school are greater than those who studied humanities. So one variable is quantitative or continuous, the other variable is binary dichotomous. So to do that, I will navigate to analyze and then to correlate, and then I'll click on bivariate, and after that I'll scoot marks in statistical analysis and interpretation, and second I will scoot science versus humanities to variables list, and after that I will click OK, and it gives me the correlation coefficient which is 0.425, but this is highly significant. So we can say that there is a medium term or moderate correlation between marks of students in statistical analysis and interpretation, and whether they studied science or humanities in their high school. Since the sign of this correlation coefficient is positive, so it means there is a positive relationship between student marks in statistical analysis and those who studied science in their high school. Since we coded science as 1 and humanities as 0, so when we move from 0 to 1, then the marks of the students are expected to increase because the sign is positive. In order to prove this or to confirm this, let me see the scatter diagram of these two variables. So let me use simple scatter of the two variables, that is mark in statistics. So I have already done this, so let me do it again. I'll send this to y and this science to x, science versus humanities to x, and here is my scatter diagram of marks obtained by students in statistical analysis and interpretation by science and humanities. Since we coded humanities as 0, so this is the scatter of marks obtained in statistics for those who studied humanities in their high school, and since this dichotomous variable is coded as 1 for those who studied science in their high school, so this is the comparison of marks obtained by students in statistical analysis and interpretation by those who studied humanities in their high school, and this is the scatter of marks obtained in statistical analysis for those who studied science and science in their high school. So if you compare both marks, so it shows that the students who studied science in their high school on the average got higher marks in statistical analysis as compared to those who studied humanities in their high school. Since the value of the correlation coefficient was 0.4 something, so let me see it. What was the this value was 0.425. so there is a positive correlation between marks obtained in statistical analysis and interpretation and the students being science studied science in their high school. So this is very simple and understandable. I hope this is quite informative for you. Let me also check another scatter diagram of those using a simple dot diagram for both of these variables. So press OK, and this is the another chart. So this is the X graph. So these are the marks obtained by students who studied science in their high school, and this shows the scatter of their marks in statistical analysis and social sciences, in statistical analysis and interpretation. And these are the marks of students in statistical analysis and interpretation by those who studied humanities in their high school. So if you compare both, this means that on the average the marks of those who studied science in high school are greater in statistical analysis and social sciences as compared to those students who got marks in statistical analysis and interpretation by study and they studied humanities in their high school. I hope this is quite interesting. So kindly share this video with your students, colleagues and friends, and share this video so that it could reach to the maximum possible number of people. Thank you.